going to show you about the code of machine learning Coursera from end to end. I will show you here the second week solutions. Already I discussed here how to submit your solutions for first week. Okay, so let's see. Uh, go through the main file. Actually, we will download the files from the Coursera machine learnings. From here, your instructions on my submissions. From before that, you will get the file of here of your course. If you purchase the course, then only possible. Then you will after taking these things, you will go to you will get the file of like this zip file. So you will unzip it. Okay, after unzip, you will get the file and you will put the file in your machine learning proper path to run it and to execute it. And you will notice that there will be the PDF file. I will recommend it to you highly that go through the PDF file very thoroughly. Okay, and I will recommend it to you one more thing that when you are do something before starting the programming, so go through that week lecture notes if you have written anything, or neither go through the lecture notes of PDF file formats what's the individual is given. Go through it first. So what's happened, this is all the problem solutions, I mean how to solve the problem, the approach of the solutions is described here in this application. So go through it, and there is this much of file is there. No need to solve all the files because you the star marks files only you should have to solve it. So there is the five uh, MATLAB files you should have to submit it. Okay, and it is indicated that star mark you should have to submit. Now in the descriptions is given that in the throughout the exercise, obviously let me describe something that you will use the ex2.m and ex2 underscore reg. It's two files. This is the two main files, and all the other files are the functions, and no need to of the submit because it actually submit your result to their server. Okay, and there is a two data also given, so you can click on it and you can see let's in the data format once first time. Let's see the data format once that ex2 dot data once is the into three-dimensional matrix, and the other one, sorry, and the other ones, this one is n into three-dimensional matrix. So in these two data they are operating. So go through the PDF file first, and let's see. First you should have to go through the logistic regressions. In the logistic regressions they are suggesting that before starting any program just visualize the data. So visualization of data is given on the plot data file. So in the plot data file we'll plot the data of like the positive is y is equal to 1 and negative is equal to y is equal to 2. They're given already the code, no need to worry about that. You can paste the code in your programs and you can visualize the data from there. So let's go there and let's see the plot data, how does it look like this. In the plot data, see in the plot data is equal to load of I'm loading the one number file data, and one number file data I'm defining here input and the output, and I'm defining here positive and negative number which ones, and I'm in paste on their lines. So actually what's happened in these lines, they find in the positive values, and the positive values is defined over a plus, and line width is equal to 2, and marker size, I mean how big it will be, it is defined as a 7, and the negative also it is make a round plot it, and marker face color, I mean the color of this 0 will be like y for evil, and marker size will be 7. So you get the data from there, how it would be like that. Okay, so it is the plot data file, visualizations of data. Now go through it. Now go to the warm-up exercise, how you can do the logistic. Their Sigmoid functions is given there. So before that you should have to when you call the logistic functions or any logistic functions, cost functions, okay, regularization functions, there is you can use the h theta of x value. So h theta is x value actually is the sigmoid function value, and the sigmoid function values is given over here. Hg is the sigmoid function value, and theta transpose is theta transpose of x, and it is simplification equations is given like here. So it is a sigma dot m, it is given over there. So go through it and let's see, it is given over there in sigma dot m, actually already is given. Okay, So if it is not in your code, so we will modify it and we will write it properly, very properly. Okay, now go down, and now you will go to your exercise, and your exercised what happened, the plot data, uh, you can see the plot data. Okay, how you can see, you will go to the ex2 and you will just save it, and to run the program, to control F5 or by running from the MATLAB home, no problem. Then let's see, the data is look like that. Okay, so it is the first problem, and let's see, my program is up to here. I'm not going to tools. One by one I will discuss and I will solve this thing. So now let's see and go down, and cost function and gradient you should have to calculate, and it is in cost function dot m file. So go to the cost function and m file, and cost function dot m file is this there, and here you should have to do the logistic regression cost. Okay, logistic regression cost a value of j theta. You will write the functions of like this way, and obviously when you will do, remember one thing, this multiplication is not possible, so why you should have to take as a transpose matrix, and 1 minus 1 you should have to take as a transpose matrix. Neither this thing is not possible. And why, from where you will get the h theta of x, or h theta of x is the sigmoid function value, and this function value is already defined that it will be the sigmoid theta transpose of x. Okay, sigmoid theta transpose of x. In your code you will do that. So it is the jth values and cost function value. Let's see the cost function value. I see, let's say here I am defining here h theta is here, and after that I am defining here the cost function's value. After that you should have to calculate the gradient. The gradient is the different over here. See, the gradient is the different over here like this. So you should have to calculate the gradient very properly, and you will write the code for that. Okay, and the x, remember that x, you should have to put the x of j for all the values, and this multiplications of x is not possible like that way. That's why you need to take the transpose of that matrix, of that values, and that values will after that is able to multiplication it with x. So when you complete your cost function values and you will submit your course from ex2.n, then you will get the values of the defining that 0.693. So let's see, my program is paused, so let me continue and see that the values is 0.693 is properly up to here, is good, right? Now go to the downs, and you will use the f mean unc, and the details is given over there, or you can get the help of f mean unc from the MATLAB or from the Octave folio also, no problem. Now let's see, it is a different over, you will go through all those things very properly, and so the functions it means is how it is look like that. So it is given over here, and the main things is given over here, also look like this, and you will use these things in your codes of cost functions, where it is called is cost function unc, and cost functions, when where you will use it, you will see the cost functions values is about of uh, 0.203. Okay, 0.203, and this values will be called from the plot decisions boundary from this functions. So I'm here now in cost functions. So cost function is complete. Down, go to the plot decisions boundary, and with this plot decision boundary we will plot of this like way. This code is given already, I discussed here, and most of the code is written over by them, and you should have to write some of the code over there. Okay, plot decisions boundary, this one. So when you run the plot decision boundary of this code and very properly after using a cost, if you can see, then you will get the value 0.203, and already I was called 2. Uh, sorry, these values now, sorry, let me 203, yeah, 203 is the next values will be, I think, yeah, 203, these values you will get these values, and plot decision is boundary, it is called the plot decision boundary. This boundary will become, and the value will become as, it will be shown as 203 as you expected. Okay, now let's go to the grounds and evaluating the logistic regressions. In the logistic regressions, you will do another things that will get the cost. After getting the cost, we'll go to the predict.end, and the predict.end solutions you will now able to submit when you are successfully predict these things. So let's see the predict.ends. The predict.ends is like that, getting the predictions of this data values of the predictions, how much predictions you are getting. This predictions will become from there. So it will show the output of like this previously before. So regularize. Now I'm coming to the topic of regularized logistic regression. In the regularized logistic regressions, now you will use the ex2 underscore reg regularized functions. This MATLAB code actually. Here you will plot the data against. So where you will plot the data? Actually, we will plot the data into plot data functions. Plot data code. In the plot data code, let's say I'm using two times. Here I'm using the first time of like this. So this is no need of that now. So comment it, sorry, and unlock the second data. Okay, fine. Unlock the second data. Now set the code and now visualize the data of the second data. So let me see. Press the enter. Press the enter. So okay, fine. Now I'm going to visualize the of the first. If okay. Now run the program. Running the program. Now see the plot data. The program is running and see the plot data, and plot data will come as like this for second data type. Okay, so you'll get the values of like this, and feature mapping, you will feature the map of the map feature.m in this file. So go to the m map feature.m file. There you should have to write the code for that your map features of x, but x will be coming as like this. They're taking the x to the power of 6 values up to and one as the first input pass values is here. Remember of that. And cost functions of the gradient will be like this of regularized. It is called as regularized cost functions logistic regressions. It is very important. It is a regularized cost functions. Okay, and the cost function and the cost function gradient will be different because it is the gradient for j is equal to 0 of this value and j is equal to 1 for that value. Let's say j is equal to 0's values are similar of like this part, so you can call the j is equal to 0's values here. After that you can add these functions. So you will write this code for map feature. So you will write the cost function dot end. We will solve here cost function dot m. Okay, cost function dot reg. So in the cost functions of the reg, let's see logistic regressions cost functions. I'm defining here the sigma h theta's values. After that, I'm calculating the cost functions values over here. It is a long code, so let's see once more times. J is equal to of like this, then it is coming as lambda by 2m. Here I'm taking the summations of two times. There is no need, you can take the summations over one time of square root of square function using the square function. And I'm calculating that the gradient is here two times, one for j is equal to 0 this line, and another is for j is equal to 1 of this line. You can modify this code into one line also, it can be possible. So let's come down. So when you run the code and you will get the solution 0.693 like that above. So my program is already imposed and I got the expected output 0.693. So now learning parameter using if in ENC, it's already using and plotting the data of decisions boundary. Plot decisions boundary. Here we will write the code. You should have to print the code, and the code format is already given over this, and the code format for decisions boundary dot n. Sorry, let me see one. It is the that one. For decision boundary dot n. We can calculate the plot decisions boundary. Okay, from here of your code. So let's run the just continue the program and let's see the plot decision boundary of the code. So let's boundary also till now not also happen. So let's go and let's see the plot decision boundary. Okay, yeah, now the code is in. The plot decisions boundary will be come as like this. Okay, so now go to the ground and the plotting decisions boundary will be like this. So by changing y is equal to 0 to 1, so you can see the data underfitting overfitting concept from here. Okay, but if you change the values of the y in the different values, you will get the underfitting overfitting to a concept from here. By visualizing data, I will recommend you uh, to do that. Okay, because the underfitting overfitting is the very important for you by using the actually sorry, by using the lambda values is not defined for here. Lambda values is there somewhere. I forget. Just we'll go through the PDF and I think you will get. Now the optional ungraded is like that if you change the lambda values, then it will give you the different results. So optional exercise will be over there. If you change the lambda values, then you will get the underfitting concept and overfitting concept by this. Say this equation overfitting will be that, this is the underfitting. So you'll get when lambda is equal to 100, you will get the underfitting concept. So, and at the last, if you submit the all the programs, then your mark will be evaluated. So here I think he will get the lambda value. You can exercise 2. So go to the exercise 2 and let's see the lambda values as well. Yeah, y value lambda values is 1. If you change the values is 100, so let's see and change the program and run in the program and let's see what's happened. How the plot, this plot will be like this. Now it is enter, and after that press enter because it is paused. So let's see, it will be the value will be map is not changed. I think it is a underfitting or overfitting concept is coming here. So let's see, it is lambda is equal to 0, so the value will be different. So it's the pause like this and pause. This boundary is not changed. I think something went wrong because I'm changing the another values. That's why it's not working properly. But you will do it your own self because of that values. Okay, it is going to change. I think I'm doing something wrong. But and let's see the other things. So you will implement here this code at a glance. Last time we will implement here this code. Okay, you will no need to modify that one and no need to modify that one. It is the map feature values. From the map feature values, I think you will all be given and you will do these things for your plot data for data times 1, and when you will use the reg function, regularized function, then you will use the second one. So in the next part I will, and the submission time, I will use the first one. So comment data and uncomment that one. Okay, save it programs and plot decisions boundary will be look like that. Let's say predictions will be look like that, and Sigmoid is will be look like that. So now go to there and submit the solutions. So maybe we will submit the solutions. Obviously I will submit that one. Fine, fine. Yeah, plot decision boundary games. Now the submission. Type submit. Then asking for the lost email and the token. Press enter. So it's good. Okay. So all the things will be nice works. So thank you for watching. Please subscribe my channel, like my videos, and stay in touch with me. I will update more and more about the machine learning course of the video. Thank you. Bye.